For the past 5 years, I've been diving into AWS almost every single day. In this video, I'm going to take you through my journey on AWS as a cloud data engineer, sharing the kind of projects I have worked on and the services that have been my go-to tools. This is not going to be your typical zero to hero AWS tutorial. Instead, I want to give you a real world perspective of what it is like to work as a data engineer in the AWS ecosystem. I will be breaking down the kinds of projects you can expect, the services you are likely to use, and most importantly, I'll be sharing hands-on experience that go beyond just theoretical knowledge. Hey everyone, my name is Nitin Srivastav, and in this video, we will be focusing primarily on building data lakes and data warehouses, the bread and butter of any data engineer. I'll walk you through the AWS services I have used, sharing the pros and cons, and throwing in some practical code examples along the way. With 16 plus years of experience in building data lakes and data warehouses across different industries, I have got a lot of insights to share. So if you are ready to get a genuine, experience-based look into the AWS data engineering, stick with me. Trust me, you are going to learn a lot from the next few minutes. One of the most important and popular type of project in my AWS journey has been data warehouse migration. Picture this, an enterprise with an existing data warehouse running on traditional systems like Teradata, Netezza, and they want to move everything into Amazon Redshift now. Let me break down what this typically looks like. These migration involve converting existing data pipelines and ETL processes into AWS services. All those SQL files that were running in their traditional system, it will run in Amazon Redshift now. You will schedule this to run at desired frequencies, and sometimes that means some serious SQL conversion as well. I'll give you a real-world example. In one project, we were migrating from Teradata to Amazon Redshift, and we hit a classic challenge: user-defined functions. The original system had UDFs written in C programming language. While Redshift does not support C, it does support UDF in SQL or Python language. So we have to convert those UDF written in C into compatible Python UDF and then use it in our SQL queries. That's the kind of technical gymnastics you will often encounter in migration projects. If you want to dive deeper into Amazon Redshift, I have got a detailed video linked in the description. Check it out to understand the internal architecture and how it works. When working with Redshift, you got few key approaches. You have to run SQL commands via scheduler like Amazon Managed Airflow, and which will run SQL queries sequentially, or you can create stored procedures for more dynamic parameter handling. And I will share both of these approaches in the hands-on in the later part in this video. I have spent almost every day of the last 5 years working with Redshift. And let me tell you, the migration projects are never straightforward. They require a mix of technical skills, problem solving, and understanding both the source as well as the target systems. For beginners wanting to understand more, I will link some starter resources in the description. Trust me, these migration projects are where you will really learn the nitty-gritty of cloud data engineering. Now let's talk about another critical project type, creating a data lake in AWS. Enterprises often want to build their own data lakes, and there are typically two main strategies. First scenario is an enterprise already has a data warehouse and they want to start building the data lake now by pulling historical data from their existing warehouse. It is like taking your current data repository and expanding it into a more comprehensive data lake. I will share a challenging project which I worked on. So we were dealing with on-premises SQL Server, and it was having more than 5 petabytes of data spread across different instances. Moving that massive volume of data into Amazon S3 was not a straightforward task. So we came up with a very novel approach. We categorize the data into hot data, which is frequently accessed by the business, and the cold data. Cold data refers to the data which right now the business is not consuming very frequently, but they have to retain that data in order for some compliance. So what we did is, for cold data, we created SQL Server instances backup, and we migrated those backup as is into AWS. And when required, we were just restoring the backups into RDS SQL Server instance. For hot data, we actually created a PySpark application from scratch, which will connect to their on-premises SQL Server instance, do some basic transformation, and will migrate data into data lake. So the data lake hydration was done in two ways. We were directly moving data from their on-premises by using PySpark application, and we were bringing in the backups as well, and then exporting the data. I personally wrote every single line of that PySpark code, and I received great appreciation for that solution. I will link the AWS public blog about this project in the description for those who want to dive deeper. When building a data lake, data hydration is your very first critical step. Most enterprises start by exporting data from existing databases or data warehouse, essentially transferring their historical data into the new lake architecture. All right, here is what we are going to do in this video. I will be walking you through the real-world examples, sharing actual code, and showing you how we leverage key AWS services to build data infrastructure. We will focus on Amazon Redshift for data mart or warehouse development, S3 data lake creation. I will also show you how we can run PySpark applications in AWS Glue as well as Amazon EMR. And at the end, we will use managed Airflow to orchestrate and run the jobs in Glue, passing to EMR and then to Redshift at the end. I know many of you want hands-on learning, so I'll demonstrate how you schedule and execute jobs in Manage Airflow. I will also do a quick walkthrough of the scripts I'm using, and at the end of the video, I will share how you can download all the resources used in this video. So let me be clear again, this is not a dive deep masterclass or a zero to hero tutorial. This is a practical overview of the kind of projects you can expect in AWS data engineering. Take it as a crash course in AWS data engineering. My goal is to give you enough practical information that if you are a data engineer with some background, you can log into AWS and start building data pipelines. And for deeper learning, I always recommend the official AWS documentation and public blogs. They are treasure troves of knowledge. So later on this video, we'll go hands-on with Amazon Redshift, AWS Glue, Amazon EMR, and Managed Airflow. Now, these four components form the backbone of most of the AWS data engineering projects I have done so far. While we'll touch other services like EC2, Lambda, CloudWatch, SQS, etc., the focus for this video will be on building data mart and data warehouse and data lake, and how we can process the data using Amazon EMR and AWS Glue and use that processed data into Redshift for reporting and visualization purpose. Ready to dive into AWS ecosystem? Let's start with Amazon Redshift, one of the most powerful data warehouse solution from AWS. Let me walk you through its key features. First, let's understand the fully managed service aspect of Redshift. What this means is that AWS handles all scaling, management, and maintenance operations. This allows you to focus on your core business requirements. Now let's discuss the columnar storage feature. Redshift stores data in a column-oriented manner rather than row-oriented. This approach is specifically optimized for analytics and provides significant performance benefits for query processing. A crucial feature to highlight is the massively parallel processing. This architecture enables Redshift to distribute and process your workloads across multiple nodes simultaneously, ensuring efficient query execution even with large data sets. Regarding data distribution, Redshift offers 4 flexible styles for data placement. These are key, even, all, and auto. This flexibility allows you to optimize your database design according to your specific workload patterns. Another important aspect is sort keys. These are fundamental to optimizing query performance in Redshift. When properly implemented, sort keys significantly reduce the amount of data that needs to be scanned during query execution. Consider it like partition pruning or partition elimination that happens in other databases. Lastly, we have Redshift Spectrum, a powerful feature that enables you to directly query data stored in Amazon S3 without loading it into Redshift tables. This provides immense flexibility in managing your data lake architecture. That covers the fundamental feature of Amazon Redshift. There is a detailed video on Amazon Redshift on my channel. I will share the link in the description box below. If you are interested, I will highly recommend to watch that video as well. Next, I want to explore AWS Glue, Amazon's fully managed ETL service. Let me explain its fundamental components. Let's understand that AWS Glue is a serverless AWS service. This means you don't need to worry about infrastructure management, no servers or nodes to procure, no maintenance required. AWS handles everything in the background. A key component is the data catalog. This serves as a centralized metadata repository not just for Glue but also for other services like Athena and Lake Formation. What makes it particularly valuable is its compatibility with various systems. You can use it with Spark or Hive on EMR or even as an external database on Redshift. Next, let's discuss Spark ETL. This is primarily where AWS Glue shines in running ETL jobs. It leverages Apache Spark's powerful processing capabilities to handle your data transformations efficiently. For developers, AWS Glue offers Python job support as well. This means you can build and run Python jobs directly within the service, giving you more flexibility in how you process your data. Personally, I prefer AWS Lambda if I have to create a standalone Python application. I have used Python shell in Glue sometimes, but it was always in tandem with my PySpark application. So if there is any prerequisite for my PySpark application in AWS Glue, I will create a Python application, say cleaning some data files before actually processing it. In such cases, I may create a Python job in AWS Glue. However, if it is a standalone Python application, I prefer to use AWS Lambda for it. The crawler feature is quite impressive. These automatically discover and extract schema information from your data sources, saving you significant time in data cataloging. Lastly, there is a Glue Studio, a visual interface that makes creating ETL jobs much more intuitive. Instead of writing complex code, you can design your data pipelines visually. These components work together seamlessly to provide a comprehensive ETL solution. If you found this overview helpful, please support the channel with a like and subscribe. Next, I want to talk about Apache Hudi. It's an innovative data lake technology that transforming how we manage large data sets. Let me explain the 4 key features that make Apache Hudi particularly valuable. First, we have open source data lake capabilities. Apache Hudi provides robust functionality for building and managing data lakes effectively. Being open source means you get the benefits of community-driven development and transparency. Next is ACID transactions. Now, this is crucial for data consistency. Hudi supports insert, update, and delete operations on Hudi tables, ensuring your data modifications are atomic, consistent, isolated, and durable. The third feature is versioning. Hudi provides comprehensive support for data versioning and rollback capabilities as well. This means if something goes wrong, you can easily revert to a previous stable version of your data. Finally, Hudi offers seamless integration with AWS services. It works smoothly with AWS Glue, Amazon Athena, and even Amazon Redshift, making it a perfect choice if you are operating within AWS ecosystem. The combination of these features make Apache Hudi a powerful tool for modern data lake architecture. It addresses many traditional data lake challenges while providing the flexibility and reliability needed for large-scale data operations. The other popular data lake formats in the market right now are Apache Iceberg and Delta. I have personally used Apache Hudi and I really like it. Next, I want to give you a quick overview about Amazon EMR, which is AWS Managed Big Data Platform. First and foremost, Amazon EMR is a managed big data platform. What does that mean? This means AWS takes care of the complex infrastructure required for processing massive data sets, allowing you to focus on your analytics. One of its most appealing aspects is that it's elastic and cost effective. EMR allows you to scale your resources up or down based on your workload demands, ensuring you only pay for what you actually use. A significant advantage is its seamless AWS integration. EMR works harmoniously with other AWS services, creating a cohesive ecosystem for your data processing needs. The platform is also flexible and configurable. You can customize your EMR clusters according to your specific requirements, choosing from various frameworks and tools. When it comes to performance, EMR offers high performance and scalability. It is designed to handle massive workloads efficiently, with the ability to scale horizontally as your data processing needs grow. Finally, EMR is secure and compliant. It comes with the robust security features and compliance certificates, ensuring your data remains protected while meeting regularity requirements. These features collectively make Amazon EMR a powerful choice for organizations dealing with big data processing and analytics. Lastly, I want to give you a quick overview about Amazon Managed Workflows for Apache Airflow. In short, we call it MWAA, a managed orchestration service for data pipelines. Let me explain its key features. At its core, MWAA, I will call it Managed Airflow going forward, excels in workflow orchestration. It orchestrates complex workflows within the AWS ecosystem, allowing you to automate and manage your data pipelines efficiently. A standout feature is its AWS integration capabilities. The Managed Airflow provides seamless integration with AWS services, enabling comprehensive data management across your entire AWS infrastructure. When it comes to scalability, Managed Airflow truly shines. It offers automatic scaling and provisioning for efficient operations, ensuring your workflows run smoothly regardless of your workload size. Managed Airflow ensures secure and compliant workflow orchestration, protecting your data and processes throughout their lifecycle. Finally, let's talk about cost efficiency. Managed Airflow follows a flexible, pay-as-you-go model suitable for diverse use cases. This means you only pay for the resources you actually use. These features work together to make Managed Airflow a robust solution for managing Apache Airflow workflows in the AWS cloud environment. So this is all about the overview of different AWS services, which I personally feel are key for any AWS data engineer. In the next section, we'll start with the hands-on. So I'll log in into my AWS console and we'll proceed with the demo.
So I have logged in into my AWS console, and when you log in it for the first time, it may look slightly different for you, and it is totally normal because the AWS homepage keeps on changing over the time. And you can see there is a lot of information on this console. There are one more important thing is select the region in which you want to build all your services, because there are different regions and you can choose your preferred region for it, but make sure that all the services are going into the specific region. You can search any AWS service using the search box at the top. I think this is the most convenient way to search for any jobs. There is another way by clicking on the three horizontal buttons and then looking for all the services. So this shows all the services in AWS. And this is like very confusing. So I personally prefer using the search box. And as you keep on using more and more AWS services, you see this recently visited tab and the services will come here. I also want to talk about Amazon S3, which is the core storage layer, and all the data which you will store will be stored in S3 buckets. Consider bucket as you have drives in your PC like C drive, D drive, E drive. Similarly, you will have buckets in your AWS account. The bucket name should be globally unique, not only limited to your account, but globally it should be unique. So let me give a name and let me add some number at the end so that globally I make sure that it is unique. I will keep the other options as default, keep public access blocked until unless you explicitly want somebody from the outside the network want to access your S3 files, and I will create a bucket with the default options. So bucket is like your drives, and inside drives you create folders. So similarly in your buckets also you will create folders and you will store your files inside the folders. So I will create a folder. I will call it as raw because all the raw input files I will be saving in this folder. So let me create folder here. My folder is created. I will place a sample dummy file, raw customers.csv. It has around 50 records for customers, and I will upload this file. So I've created a bucket, a folder inside that bucket, and uploaded a CSV file in that folder. Next, as part of this exercise 1, I want to show you different components of AWS Glue and then create a crawler. And leveraging that crawler, I want to read this raw CSV file and create a table in catalog. So Glue has catalog tables, data connections for JDBC connectivity. You can see the database, tables, schemas, and crawlers are what we are going to create next in this exercise. Let's click on crawlers. A crawler connects to data store, determines the schema, and then create table in your data catalog. Click on create crawler, give crawler a name. Description is optional. Click on next. Select your data source. In my case, it is S3. I will select the path where the file resides. So I just now created this bucket. And then I will select the folder in which the file exists. So you see, I have selected the folder. Now I have to create an IAM role here. IAM role is like you create a role and then you associate a service to that role. Whatever the privileges you will assign to that role will be assumed by the service. I also have to create a database. So as we know, crawler will be creating a table in the catalog. So I want that table to be created in this database. So let me give it a name and I'll create a database. So now I have a database and I want my crawler to create the table inside this database. I can give a prefix for the name. By default, it takes the last prefix or the last folder. And you can schedule it crawler also. Right now, I'll keep it as on demand because I want to run it on ad hoc basis, review everything, and then click on create crawler. So I can see my crawler is created. I will run the crawler now. The crawler is starting. It may take around 1 or 2 minutes for the crawler to run and complete. So you can see it is in running state right now. It periodically refreshes automatically. If you want, you can also click on the refresh button on the top. Schedule is on demand. Source is my S3. There is no classifier. So classifier is something, if you are dealing with a complex file, you can determine the file format using classifier and associate your class crawler with that classifier. In this case, it is a CSV file. So by default, it should be able to determine the schema automatically. So I see the crawler is complete now. Let's go to databases. And I can see a table raw, which is the folder name, is created. The classification is CSV. It automatically determines it. Let me see the table overview, and I can see it is able to determine the column name as well as the column data type accordingly. If you want to view the data, click on Actions, View Data. It will take you to the Athena console, which is another AWS service. So if you want to read S3 data in an interactive manner, then you can use AWS Athena. I will give the database name and table name, and I can see the data is looking good. All the columns are properly aligned. So the crawler was able to determine a proper format for the file and read the column name from the header and create a table in AWS Glue catalog. And I am able to query that S3 CSV file using Athena, and the data also looks good. So yeah, so the very first demo I wanted to show you that how we can easily use crawlers to create table in Glue pointing to S3 path here. And in this database, this S3 path, this is a column. Now creating an ETL jobs in AWS Glue is very popular. I have personally used it a lot. So I create lot of ETL jobs in AWS Glue, and it's my preferred platform for it. So as part of this exercise now, after creating a crawler successfully, I want to create a ETL job. So my table exists here. Crawler is looking good. Let's move to the next exercise now, which is creating a ETL job in AWS Glue. So you can obviously create your own script, or you can even use visual ETL. And before we proceed with the Glue ETL job, I will go to S3, and I have already placed some files. So right now in raw, we just placed one file for demo purpose. But yeah, this is my actual input file. I have created 3 folders: customers, products, and transactions. And all the 3 folders have one file in it. So 3 CSV files. And if you map it to the Medallion architecture, input files is like my bronze layer where all my input files are there. Output files is my output layer. You can call it as my silver layer. So I will be reading CSV files present in input file and converting into Hudi data lake tables in output files folder. Before I proceed, I will go to IAM. I mentioned earlier that we create roles, and these roles, we assign some permissions to the roles so that when my service runs, it assumes those permissions and have the sufficient privileges. Now you see this role was created when I was running the crawler, and this policy was custom policy was attached when I created a crawler, and you can see in this policy, the S3 access is granted to the crawler because it has to go to that particular S3 path and then read my CSV files. So this custom policy was created. What I will do is I will attach another policy to it. S3, I'm granting S3 full access because throughout this demo, I will be using this role and different S3 path probably. So I'll just add it. But in your production, probably you will have again fine grained policy with limited to specific folders only, right? So my idea is very simple, a glue job, which will read data from S3 input file folder and will convert it into a Hudi table in output file folder. This is the Visual Studio where you can drag and drop your source, target, and transformations. So I'll quickly do a demo of Visual Studio. So I'm reading the CSV from S3 and writing into Hudi table. I have already created a detailed video of it and it is there on my channel. So if you want, I'll share the link in the description box below. Go ahead and see that video in which I have shown exactly how this Visual Studio works and why I don't prefer using Visual Studio a lot. So you see here, I'm just selecting some of the options for my data source, S3, CSV file, and then for the target, I will choose Hudi as my target format. So there are a bunch of options: Parquet, CSV, JSON, Hudi, Delta Lake. I will use Hudi in this case. I'll give some table name. I'll choose some of the options. I'm not going to run this job because I actually want to run the script. I'm just showing you that with Visual Studio, if you want, these are the options and you can use it. And as I said earlier, there is already a detailed video on Visual Studio converting a CSV into a Hudi table. So go after this video, just go to my channel, see that video. The link is in the description box below. I'm just showing you all the options available for you in the Visual Studios. So once you set your source and target, just save the job and then probably trigger it. If you have already assigned proper permissions to the role, your job will successfully complete and you can see that your target S3 will have the Hudi information. But yeah, coming to the actual exercise, we are going to create job and you have option to create Python shell. Ray I have not personally used yet. And Python shell, I generally use AWS Lambda for Python work until unless Python shell is the first step. And then in the next step, I want to use Spark Glue. Then to create a chain, I use it. You can upload your script or you can start fresh. So as soon as I click on create script, boilerplate code is generated by AWS Glue. And you can see it has imported libraries and a boilerplate code is given to me. So what I am going to do now is I will replace this boilerplate code and I've already created a glue script. I'll paste it here. The glue script and all the resources I am using in this demo will be shared with you. So go ahead, download it for free and use it for your purpose. This configuration is very important if you are creating a Hudi data lake format. There are three input parameters, basically the bucket name, input path, and the output path. So you see at the top, I'm just importing all the libraries and the modules which I need for this job. I am using object oriented programming style for, so I have seen many people who knows how to code in Python and also PySpark, but they refrain from using OOP style. So I will strongly suggest you use object oriented programming. There are three parameters here: bucket name, input path, output path. I'm creating a glue context and then also creating a Spark session from it. And then I'm setting three parameters: bucket name, input path, and output path. I've created a method where I'm reading the raw data. So I will read raw data, the CSV files from the input file folder. I just now showed you in the S3 bucket, I have three folder: customer, products, and transactions. There is a CSV file in each. So input file, customers, product, and CSV. So I will be reading those three files using this method. And I will return a data frame to it. The next step is to process. So I'll process the customer. I'm doing a basic, very basic level transformation. I'm making sure that email is in lowercase, the country is in uppercase, and then I'm adding a new column which is load date with the current date value. Similarly, for the product also, I'll make sure that I'm applying a basic string level operations, and then I'm adding a additional column load date. And even for transactions, a load date column I am adding. Then the next method is to write to Hudi. So I am writing a Hudi table back. So I'm reading a CSV, returning a data frame, adding a new column load date, and then writing it into Hudi format. And these are the options I am using. If you want to know more about it, each option I have explained in the previous video where I have given a demo. So, and then I will be calling this run method, which is the main method, and it will be calling all the methods I've created above. So first I'll create a customer data frame, product data frame, and transaction data frame. I will process my customer data, product data, and transaction, and then I will write my customer, product, and transaction. So at the end of this glue job, my expectations is when this job is complete, I will have three tables: customers, product, and transactions, and the table type will be Hudi. So let me give a name to this job. IAM role, as I mentioned earlier, whatever IAM role you will grant, it will assume those permissions. This is a Spark job. You can choose Glue 4, 3, whatever you want. I will keep it as Glue 5. Language is Python 3. Worker type, there are different workers you can choose. I will go frugal. So I will choose the one which is the smallest and the least expensive also. I'll keep the workers as 2. Then there are a bunch of options for you. You want to generate job insights, you can enable it. Then job bookmark, if you have already processed the file, you don't want to process it again, enable it. I'll keep it disabled for now. And then flex execution, if it is a non-critical load, you can use a flex execution. I'll keep the timeout to 10 minutes only, because I don't want my job to continue running in case there is some problem. I want to time it out after 10 minutes to save some money. Then where the script will be stored, and bunch of other performance monitoring options for you, logging, Spark UI. I'll keep everything as default. And this is very important. I want to use Glue data catalog as my Hive meta show. If it would have been a JDBC connectivity, like connecting to RDS or Redshift even, I would have added a connection here. Now this job parameter actually is very important, because I am going to use Hudi as my data lake format. So I have to specify here whether it's Hudi, Iceberg, or Delta. In this case it is. And then there are two properties which I mentioned earlier, and those two properties you have to mention here. So this configuration parameter and data lake format and data lake format, these two are very critical parameters you have to add in your Glue job, else your Hudi job will fail when you will trigger. So because of these two properties, the Glue job knows that it is going to handle Hudi data lake. And the other three parameters were my bucket name, my input path, and my output path. So I'll add these three parameters as well. Let me add input path. And don't forget that there are two dashes in front of the parameter name also. Many times I see people forget that. So please make sure this is the syntax you have to follow. Every language has a syntax. Similarly, in Glue, if you are defining any parameters, you have to follow this syntax of giving two dashes and then your input parameter name and the value. So I've given bucket name, all my parameters are set. I think I am good here. An output file is where I will be writing my Hudi tables. This looks good. I will just quickly go through all the options. This is the script. So you see here, I have used the S3 path, the bucket name, input path, and then read the customer, read the products, read the transactions, right? So yeah, this looks good to me. I'll process it. And then finally, I'm passing a table name. Customers, product, and transaction is my table name. Customer ID, product ID, transaction ID is my primary key for my Hudi table. I will save the job now. Job is saved, and I will trigger the job as well. So job is running now. You can see the status is running. It will take around 3 minutes for the job to complete. This does auto refresh, but if you want, you can click on the refresh button. Here in output files, I'm expecting folders to be created. Inside that, the Hudi data will be stored. So I can see the job is running. The logs have started coming. Over the period of time, when you are using Glue a lot, I will strongly recommend to go through these driver logs, because it will give you a lot of insight what is happening at the backend. Once the job is complete, I am expecting 3 tables to be created in this database. And you can see here the path it is showing. It is reading my CSV file. It is writing my Hudi table. All that information you can see in the driver log. So now it is setting up the Spark environment to execute the job. And then it will start reading the CSV file, processing the data frame, and then writing to Hudi. These 3 methods which I created, it will start running it for customers. You can see here, it will start for customer, then it will go for product, and then it will go for transactions. This job should take around 3 minutes to complete. You can see all the input arguments I have given, the temporary path it is using to store the temporary data, the Spark log path, and these 2 properties. The Spark UI is also there, but if the job is in running state, sometimes it gives an error. If you refresh it after some time, probably you will be able to see it. The job is still running. You can see here, right? The path it is showing in output file, data lake, it is writing customers. Then it will write products, and then it will write transactions. And that will be the end of the job. So yeah, let's wait for the job to complete. So I can see a data lake folder is created in output files. If I go here, you can see customers is done. So here you can see I have also created a partition on load date, and inside that I can see Hudi data is there. Internally, the format used is Parquet only. So even the Hudi use the Parquet format, and I can see all the 3 tables are created. I can see all the 3 folders are created, and corresponding to it, tables should also have been created in my catalog. So once this job is successful, we'll do a quick overview of the table as well. All right, so from job looks like it has completed. Let us just refresh it and see the status. Yeah, so status has changed to succeeded. Job is complete. Let me refresh, and you see I can see the 3 tables: customers, products, and transactions. And this is the location where the data resides for these 3 tables. I have in output files, I have created data lake. You can tag data lake to the silver data layer if you are comparing with methodology Medallion architecture. And you see the top 5 are the Hudi technical columns, and load date is a technical column which I added. So Hudi also has its own technical columns. To preview the data, we'll go to Athena. Okay, it is still loading the results. I don't know why, but let me go and check for some other table, if not customers, because it is showing results 10, but it is not showing the tabular format data. So let me check for maybe other table, products. Okay, so I can see the data here in the products table. The first 5 columns are the Hudi technical columns which it maintains, and then here are the product ID, product name, and the load date last column which I have added. Let's check for transactions. So again, first 5 columns are the Hudi columns, and then the transaction and load date at the end. So this also looks good. Let's check the customers again. I'm sure this time we'll be able to see it. Okay, yeah. So data is here and it looks good. So you see, country is in caps, email is in lowercase. The small like the string functions which we applied, that is also there, and load date and additional column we added at the end. And the 3 tables also exist with proper location in it. Job is also successful. This is the script. I will share the script I have used, and you can download it for your own easy reference. You see here the path I have given, output path, and then data lake. So you can mark data lake to the silver layer. So input files is my bronze layer, data lake is my silver layer, and in the next step, when I'll run the EMR, I will map it to the gold layer, which is like bronze, silver, gold, Mendelian architecture. So you can name it in that way also. So as part of next exercise, I want to create a EMR cluster and run some more complicated PySpark transformation. I could have done the same thing in AWS Glue. And personally, I used to work a lot on EMR. But if you ask me today, I will prefer AWS Glue over Amazon EMR until unless I have a clear use case for EMR, because it is serverless. There is no need to maintain anything. EMR also has a serverless feature now, but I still feel Glue with the catalog, crawler, and PySpark capabilities, I just feel it is more convenient to use Glue. And I will create an EMR cluster now. I will keep it as the same default size. I don't want task nodes. So it's like extra brain, which I don't need. I'm handling a very small volume. I'll keep the instance to one only. I'll keep the default VPC and subnet. I will not change anything here. I will add one additional default security group, because as part of this demo, I will be adding some extra permissions to the EMR cluster. So I will be adding it to the default security group. So I'm attaching that security group to my primary node and my secondary nodes as well. A key pair is required, because if you have to log in into your EC2, basically the EMR instances, then you need a key pair. I am using a Windows machine, so I will download a PPK, and then I will create a key pair. So my key pair is successfully created. I have downloaded it. I will just refresh and select the key pair. So my key pair is selected. I will create a new service role, and I will also create a new instance profile. So instance profile is basically your EC2 instances, which will spin up, what all permissions they will have. And I'm assigning that all S3 bucket in this account, the instance profile should have access to it. Again, I will reiterate, if you are dealing in a production environment, you want your permissions to be fine grained. In most of the projects, if you are granting a blanket full permissions, which I'm doing as part of this demo, is not encouraged, and it's not a very good practice. But I am doing it, and I'm again reiterating it that it's not the best practice. Now this cluster ID is very important, because when you will call any EMR jobs programmatically, you will have to pass the cluster ID. And in the hardware, you can see I am provisioning one primary and one secondary node. These are the properties of my cluster. It will take few minutes for this cluster to come up. This is the service role, and this is the instance profile. Once it is created, it will be highlighted as well. And the additional security group which I have added, I can see everything. So all the possible options which I have chosen, I can see the cluster is in starting state, and it will take few more minutes for this to come up. In the meantime, let me just go and check the service role for the EMR. You can see Some of the policies are already attached to it, and this is the custom policy uh, created automatically. Let me check what is this instance profile and what are permissions there as well. So in this instance profile, let me check what all permissions are granted. So you see, when I was creating the cluster, I said all S3. So you see resource here is mentioned as S3 and star. So all the S3 buckets in this account, it has permissions to it. And this also is automatically created. Let me attach couple of more policies. Since I'm going to refer to Glue catalog, I want to grant a Glue service role also, so that my EMR instances have access to Glue catalog as well. The cluster is still starting. It takes some time, 5 to 10 minutes, I think, for the EMR. So one is provisioning, the other is bootstrapping. There are no bootstrap actions explicitly mentioned. Let me check the security group also. I will add one more permission in the security group. Since I'm going to log in into the EMR from my own local laptop, I am adding a rule so that I'm assigning my IP in the security group, so that with my IP, I am able to do SSH into EMR master node. So I have added that rule also in the security group. Let me refresh and check the status now. It is still in a starting state. So you can see here, it has given the instruction. I'm using Windows right now. So it is giving the instruction. You have to download putty. This is the host name. And then the PPK file, which I created some time back, you have to use that for authentication. And then that's how I can log in into my EMR master node using putty. This host name is very important. So you see Hadoop is the user at host name. And this is the PPK I have to use to log in into my EMR cluster. Okay, my EMR cluster is up now. I have downloaded the putty, and let me follow the instructions mentioned there. I have mentioned the host name. Let me browse and select the key pair. First time it will ask, I will just accept it. This is a beautiful EMI screen which you will see. So let me use PySpark shell and see if it is working fine. You just have to give PySpark command and it will open a PySpark shell for you. First time it may take some time to come up. Okay, so the Spark context is available as SC and Spark session is available as Spark. And this is what we are trying in an interactive mode. The Spark version is 3.5.3. I will just run a simple print statement to see if my Python is working fine inside Spark, and it looks good to me, right? So as part of this third exercise, we will be creating an EMR job and we will be reading some data which was generated by Glue. So if you can recall, I'll create a PySpark code, a directory here, and here I will place my EMR code. So I've created a EMR job. Let me copy and paste. I've already created a script. And it is somewhat very much similar to what we saw in Glue. So yeah, let me do a quick walkthrough of this script, and it will look very similar to the Glue job. So again, I am starting. This is the command I will use. I will use Spark submit, and then those two configurations, if you remember. And I'm creating an application, and then I'm passing those two parameter configurations to mention that, okay, I'm going to handle Hudi data lake format now. I will enable Hive support, and there are two input parameters to this application, the output file and the input file. And then I am calculating a customer metrics, and then I'm calculating a product analytics. So two additional table I'm going to create as part of this EMR job, and it is doing some complex transformations, calculating aggregate matrices, and then storing it back into a Hudi table. And this time I will be using analytics as my output path, and you can assume that analytics correspond to the gold layer. So the golden data will be in analytics layer, and I will write data into the analytics path, and two tables will be created, one for customer metrics and the other for product analytics. So if you are ready, let me submit the command Spark. I will just copy the command and let me run the command now. So the job is running, and you can see some of the key information in the logs as well. There is an option you can see here, tracking URL, it is mentioning. So you can open a Spark UI interface as well as the Yarn, which is the resource manager. And at both the places, you can see the more detailed log for each PySpark application that is running in EMR cluster. I will wait for a few minutes for the job to complete. So you see here Spark history server and Yarn timeline server. So you can go there and check the UI, and in UI you can see more detailed information what job is running. Right now it is in running state and it is completed, and I can see the final status is succeeded. So my job is complete. So you see here Spark history server and the Yarn application server is. So you can see here the very first application you see, PySpark shell, is what I used to run the print command, and second one is this. Now in output, I see analytics folder is also created, and in analytics, I see customer metrics. This is again, you can see the process data is there, and then product analytics. So it's like analytics map it to the gold layer and data lake map it to the silver layer. And I have a simple transformations put into data lake, and then more aggregated and transform data in my analytics path. So two tables are created. Now let me check in my Glue catalog as well, whether those new tables are registered in the database or not, and if I can query it as well. So in the catalog, I can see customer metrics and product analytics. Both the tables are created, and the path is in analytics. So you see here how I am classifying my data. So the customer metrics, top 5 columns as Hudi technical columns, and then the customer ID and the aggregated matrices are stored. Let me view the data, how the data looks like. Again, it will take me to Athena, and in Athena, I can see the data is looking good. So you see, I have done the sum and average and all that calculation. So those matrices are available here. So in my golden layer, I have created aggregated fact tables, and these fact tables can be referred further for reporting purpose as well. So my customer matrices and product analytics, both the tables are available in my Glue catalog now. Let me check the other table as well. And you see here the Hudi record key. In this table, I have given 2 columns as primary key, the Hudi partition path, and then like in the previous layer, I created load date column. In this layer, I created process date column, right? So in every table, I'm creating an extra date column at the end so that it tells me that, okay, when this data was loaded. So yeah, this is about the EMR exercise. This is what I wanted to show you as part of this exercise, that we can run PySpark application in EMR as well. And generally what I have seen trend is more complex transformations, big data transformations, people push to EMR, and the straightforward one, they do it in Glue. Let me terminate the cluster because I want to stay frugal. These are paid services. So yeah, in next exercise, we will talk about Amazon Redshift. So Amazon Redshift is a fast, fully managed petabyte scale cloud data warehouse. And the last 5 years, I have worked on Redshift almost every single day because I have maintained and built a lot of data marts and data warehouse primarily using Amazon Redshift in the last 5 years. So there is a Redshift serverless option also, but as part of this demo, we'll talk about the provisioned cluster. Let me turn off these notifications, clear these notifications. Sometimes it feels like it is distracting. So right now there are no cluster, no nodes, nothing. So let me create a cluster. I will give it a name. Now I wanted to use DC2 actually because it's cheaper for the demo, but I think the trend is right now almost everybody is using RA nodes. So I will also go ahead. It will cost a little bit more, but I will go ahead and create an RA3 node cluster only because I think earlier there was DS also, and DS I think it's not available now, only DC and RA, and I think everybody will be switching to RA because it supports data sharing. I'll keep the nodes as one. It will cost around $400 per month for an on-demand pricing. I don't want to load any sample data right now. Let me give a username, which will be the admin of this Redshift cluster. And let me create a password also for it. I will just copy the password and save it somewhere. And don't worry if you can see the password, because by the time you will see this video, this cluster, I would have already deleted this cluster. So it's fine. Okay, I have saved the username and password. Let's scroll down. I will keep the option as is. You have to create an IAM role. So IAM role, as I said earlier, that whatever the permissions you will grant to IAM role, your service will assume it. So in this case, again, I will do all the S3 buckets access to my Redshift role. So this new role is created with access to all the S3 buckets, and we'll revisit this role again. Rest of the configurations I'll keep as is. I will use my default VPC and create cluster. Again, this will take some time, 10-15 minutes to come up. So till the time it is coming, let me show you reserve nodes. So reserve nodes are a excellent way to save some money. You can purchase reserve nodes, choose your nodes and duration for 1 year or 3 year, and you can save up to 60-70% of the cost. So it's if you are provisioning a Redshift cluster and you have a vision to use it for long term, I will strongly suggest to go ahead and use reserve nodes, because you can save around 60-70% of the money, up to 60-70% of the Redshift cost. So definitely, if you are an enterprise, reserve nodes are the way to go for you. Okay, the cluster is up now. Let's check this role. As I mentioned earlier, we'll revisit this role. So let's go and check what this role has. So this role has two policies attached to it. One is the custom one, and I will attach some more policies to it because we are going to read Glue data catalog. So I have to add permissions so that my Redshift cluster can access my Glue catalog as well. So I will grant Glue permission to it. I will also add some more permissions related with Athena, because with Athena you can access the data. And I will also add a data lake policy. So I will add lake formation data admin policy as well. So this is how my role looks like now. I have Athena, Redshift, Glue, and lake formation. Let's go back to the cluster now. I will use query editor. I could have used a local SQL editor as well, like dbeaver, and made a connection, but I think that would have taken more time. This is more convenient, and I can do a quick demo using query editor. I will use the username and password, which I generated some time back. Okay, so I am connected to Redshift now. Let me run a dummy query to see. Okay, so I am able to connect to the leader node. So it means my connection is successful. Now what I am going to do here is I am going to map my Glue database into my Redshift. So whatever data I have created using Glue or EMR and is registered in Glue catalog, this ARN I need to copy this ARN, which is role, because with this role I'm going to grant access to the Glue catalog. So you see here, this is the statement. The query, whatever I'm using, I will share it with you. You can download and refer to it later, or you can pause the video and see it. So what I'm going to do here is, there is a database which I created in Glue catalog, and I'm going to map this database to a schema in my Redshift as an external schema, so that I can query these tables directly with my Redshift query. And I will be using Redshift Spectrum for it. So Spectrum, it is like a black box for you. You don't have to worry. Everything is wrapped. For you, it is a regular Redshift query, but in the backend, it will leverage Redshift Spectrum and will read the data from the Hudi tables that resides in S3. So I have already created a schema here pointing to my Glue catalog, and let me run this query and see the output. So you see here, this customer table which exists here in DB ETL SQL, I am able to query this table directly in Redshift. And this is also something like a, I don't know if I can call it as a zero ETL, because I don't have to do any ETL process as such. I am reading data as is from the source, right? I am not creating any staging table. I'm not creating any merge operation, nothing. I am directly reading data from source. And it is such a fantastic feature which I really like about Redshift. You can read data from different sources directly without actually bringing in the data. So you see, I am able to read my customers and products directly. So these tables are Hudi table registered in Glue catalog that resides in AWS S3, and I am able to directly query it in my Redshift. So what I am going to do now here is, we already have bronze, silver, and gold, like the golden layer. I'm going to create a schema, and let's call it schema reporting, because I will be creating some snapshot tables, 5 snapshot tables, which I will be using for reporting purpose, right? So Redshift basically will read the data which is generated by the EMR job, and then it will convert that data into a format which will be directly consumed in reporting purpose, right? So I'm creating 5 snapshot table, and at the end I've added a snapshot date column with a default value as current date. So you see here, whenever I'm creating any data set, I'm appending a new column at the end and then assigning a default value to it. And it is actually very useful for tracking purpose when the data was loaded into the table, right? How fresh data is. So all the 5 snapshot tables are created. I will be sharing all the DDL and DML. I will be running in Redshift as well, so you can download and have a look at it. And these are the SQL queries, right? So for reporting purpose, I already have data in my golden layer, the customer metrics and the product analytics. I am using those two data sets, and then I am building some business related information. I'm converting that data into some business related information which is important for business to take some decisions, right? So I am referring to customer metrics, which is in analytics path, or the golden layer you can call it. So these 5 queries are the dummy queries built on top of customer metrics and product analytics. So let me run all these queries one by one. So snapshot 4 is in progress. And this is the last query. So I have created 5 snapshot tables using the analytics Hudi table and using customer metrics and product analytics. And I have loaded it. So let me see how the data looks like into these tables. So this is customer segment value snapshot table, and it has categorized customer into low value, medium value, and high value. So from the sample data, I have 50 records. So this is how it looks like, and the snapshot date column is added at the end. Let's check the data in the second snapshot table. This is customer activity analysis. So let's see how the data looks like in this table. I don't want you to focus on the complexity of the queries or anything. You see here, so 50 customers all are inactive in 90 days. So my point here is, I'm just showing you, it has nothing to do with your business or domain expertise. It is showing how the data is flowing. So first we process the data using Glue, and then we process the data using EMR, and then we are processing the data using Redshift. And in every layer, I'm reading the data processed in the previous step by a different service. So you see how beautifully these services are integrated. Glue, then processed by EMR, then processed by Redshift, and every next service is consuming the data processed by the previous service. So as a AWS data engineer, this is what you should focus, that how your different services will interact with each other, how the data will flow, which service is best for what kind of operation, right? So you see here, I have created 5 snapshots. I've loaded, these are some random dummy data which I have used to showcase that, okay, Redshift, you have built a snapshot table primarily focused on reporting and visualization and enabling business to take decisions. EMR for your complex big data processing, and Glue is for your very quick processing of data with less transformations. But that does not mean Glue cannot handle complex big data transformations. I personally have used Glue a lot for many handling complex big data transformations as well. So this looks good to me. I think this is good. If you are following me so far, please subscribe to the channel, like and share it with your friends. A lot of effort goes into creating these videos. So if you are here till me so far, please subscribe to the channel. Drop a comment also. I really read all the comments and really enjoy reading all your comments, right? So yeah, so we have created few tables via Glue in Glue catalog. Then we created few tables via EMR in Glue catalog. Then we created few tables in Redshift via Redshift SQL query. So this is all in Redshift. Now in this exercise, I want to cover about managed airflow. And it is a managed orchestration tool and pretty popular in AWS ecosystem. Apache Airflow as such is also very popular. I know many enterprises, they install Airflow in EC2 machines and then they manage. I personally feel manage Airflow is better. To create manage Airflow, I have to do some modification in my VPC, because manage Airflows can only be installed in a private subnet. And in my default VPC, I have 6 subnets, but all of those 6 subnets are in public. So I cannot use my current VPC. There are 2 options. I can either create a private VPC for manage Airflow and then do a VPC peering, or I can add 2 private subnet into my existing VPC and use those 2 private subnet for my manage Airflow. In this way, I don't have to do any VPC peering, and all my services, Glue, EMR, Redshift, and manage Airflow, everything will be in the same VPC, right? So let's start. I have already noted down my VPC CIDR and the subnet CIDR as well. So what I will do is I will create a private subnet now. I will choose my VPC, give it a name. I will choose a region 1A for the first private subnet. And then I will use a CIDR block, which is unused by the public subnets. So I have determined 2 slots which are right now available and are not consumed by the public subnet. So I am using those to create my private subnet. Little bit of networking knowledge is required, and it is expected from AWS data engineer. So it's not like you will only work on Glue, EMR, and Redshift. Sometimes you have to handle these VPCs and subnet route tables, NAT gateway, all these things. You should have understanding of these as well. So I'm creating my second subnet and I will give this CIDR block to it. And I will go ahead and create this subnet. So my 2 subnets are created, but the work is not complete. I have to make a connection also so that the information can be passed. So now I have 8 subnets, 6 public and 2 private. I will create a NAT gateway. So NAT gateways are basically the services that provide private subnet access to over the internet. So I'll give it a name. I will choose a public subnet now, in which I have created a private subnet as well. So let me choose 1A. And now I will allocate an elastic IP to it as well. I will keep the connectivity type to public, and that's it. I will create the NAT gateway now. So NAT gateway is also created. There is one more task before we proceed with managed airflow. I have to create a route also, so that there is a open communication between the private subnet as well. So I will create a new route table. I will give it a name. I will select my VPC, which is the default VPC, and I will create this route table. Now I have to add a route as well here. So let me add a route for all the network, and then I will list my VPC. I will the NAT gateway which I just now created. Yes. So this is also there, and I will associate those two subnet also in subnet association. So once I am done that, my work is complete. Now I can go and start creating managed airflow cluster for me. So I'll give it a name. I generally don't keep the latest version. I keep like one or two version below the latest one to make sure that there is a compatibility with my code. And now it needs a bucket to store the DAGs. DAGs are basically the code which will have all the information about orchestration. So I will create a new bucket for MWAA. It is recommended that the bucket should have versioning enabled, and the public access should be blocked for the bucket as well. So block the public. Since I am doing a demo, I'm keeping it as disabled, but yeah, it is recommended to have versioning enabled. And so I'll create a folder DAGs in it, where the code for the DAGs will go. DAGs are direct acyclic graph, which are airflow, basically semantics and syntax to create orchestration. So I will select that bucket and then the DAGs folder where my DAG code is present. If you want to install some of the dependencies, you can use requirement file also. For this demo, I'll keep it blank. Choose your VPC. So we'll choose VPC, and you see here automatically it pick both the private subnet because it needs two private subnet only. It cannot work in public subnet. Now web server access, I will change it to public because I'm going to access it via my internet, home internet. And I will create a new security group. Again, security group, how the traffic will move from one security group to another, we have to see that. Maximum worker count, I'll keep it as 1. I'll stay frugal. Web server and scheduler will stay 2 as minimum, so I'll keep it as 2. This looks good. Encryption, I'll keep it as default. Monitoring, I'll keep it as, I will strongly suggest to enable all the web server, scheduler, worker, everything, but this is a demo and I am not expecting a lot of trouble, so I will keep the logs off for now, and I will create a new role also. So you see, role and security group, almost for every service you will have a role and you will have a security group. And role, you have to attach policies to grant them permissions to different resources, and in security group you will see how the networking will happen, right? So I have clicked on create environment, and this takes 20 to 30 minutes. And when you see this prompt, it takes 20 to, it actually takes 30 minutes. Like for me, it has taken over than 40 minutes also sometimes. So yes, creating a managed airflow takes time. So yeah, just reviewing all the security group is here. So just reviewing all the properties, configurations. This security group is important because when if you can remember, we created a security group and role for Redshift also. So this security group should have access to that security, to Redshift security group. This is the default custom policy created as per the options we have selected. And I see there are a lot of resources and services mentioned here. Let me add some more policies here because our Airflow will be accessing EMR, Glue, and Redshift. So I will add corresponding policies to my managed Airflow role as well. So it should have access to EMR. Let me add another policy. It should have access to Glue as well. And it should have access to Redshift as well. So let me add that policy as well. Again, in production, you will refrain from granting full level access. You will have it a very fine grained policy, a custom managed policies limited to only those resources. But for this demo, I'm just granting the AWS managed policies. Let me add one more policy for S3. So in S3, if you are placing code in different directories, then you should grant access to that particular bucket as well where the code resides. So I have Glue, S3, EMR, and Redshift. I have granted the permission to my managed Airflow role. There is one more thing we have to do is about the security group. So my managed Airflow will access the Redshift cluster, right? So I'll copy this security group. I will open my Redshift console. I see that it is paused. So let me enable it also. To stay frugal, I paused my Redshift cluster earlier. So I will enable it as well. Okay, I can see that it is modifying, so it is coming up. But in the meantime, we can check the security group of my Redshift cluster. And in this security group, I have to grant permission to manage Airflow security group. So whenever any traffic that is coming from manage Airflow, it should allow it. So in inbound rules, I will edit and add a new rule to allow MWAA access to the Redshift cluster. So Redshift cluster 5439 is the port. On that port, it is listening to the request, and I will pass my security group. So any request coming from this security group on port 5439, the Redshift should allow it. Let me add a comment also here. And I will save the rules now. Let me double check and confirm. You can see here, there is an access. So I think we are good. The inbound rules are properly set. So from that source, traffic coming to Redshift will be allowed. Let me check the EMR as well. So EMR cluster, let me clone it as well. I terminated the cluster to stay frugal. and I'm going to create a new EMR cluster now, and I will be running jobs from my manage airflow into this EMR cluster. So rest everything will remain same as my previous cluster. I will just verify it quickly and will then create this new cluster. Okay, it is in a starting state. Redshift is also coming up, EMR is also coming up, and manage airflow is also coming up. So if you are following me till here, please subscribe, please share, please drop a comment, like, because it really motivates me. There is a lot of effort that goes into creating these videos. Share it with your friends as well. In the meantime, let's place some code, the manage airflow DAG code also. I will create a folder and I will place my EMR script into this, because for Glue we can save the job and that job will have the code, but for EMR we need a place where we can put our EMR code, and that EMR code can be triggered using Airflow. So what I am doing is I'm creating a folder, and inside that folder I will be saving my EMR job, the same job which I created using putty. I log in into the master node and then created a job and then submitted Spark submit command. If you can recall, the same code I will just place it here. So my EMR code is in place. Let's check if Redshift is up or not. It is still coming up. Even EMR is coming up, the new cluster. Let me place the DAG also. So DAG is basically a code which is read by Airflow and it generates a graph. And I will go, we will do a quick walkthrough of the DAG code as well. So my DAG is also in place. So my DAG is in place, my code is in place. And I mentioned earlier that this cluster ID is very important, because this cluster ID I have to pass in my manage airflow code. When it will run the EMR step, it has to make sure that it is passing. So it can happen an enterprise has multiple EMR cluster provisioned and they want to run a job in some specific cluster. In that case, you can pass this EMR cluster ID so that the manage airflow knows that, okay, this EMR job I'm going to run in this EMR cluster, right? So I have copied the EMR cluster ID, and this job I will just copy the file. So I'm just updating my airflow DAG with the right path for the EMR code and the EMR cluster. Okay, Redshift is still coming up. I still have one task left in Redshift. So once it is up, I will perform that task as well, and I will explain it to also. And this manage airflow, really, my experience has been when they say 20-30 minutes, it takes at least 20-30 minutes. Like, I have spent so many airflow clusters, but I'm yet to see something coming up in less than 20 or 30 minutes. It takes maybe 40 minutes, 50 minutes, even more than 1 hour sometimes. So it takes a lot of time. Okay, let me open Glue and copy the Glue job name as well, because in my Airflow DAG code, I have to mention my Glue job name as well, so that in the Glue step, it will come and trigger this particular Glue job. So let me copy this name and update my Airflow DAG as well. Okay, let me replace the DAG code now. So in the DAG code, I have mentioned the Glue job name, EMR cluster ID, the EMR file path. I will give a better name to the DAG file as well. So I will change that as well. So the Redshift is still coming up. So now what I want to do is I showed you some queries, right, which we created a schema reporting in Redshift. And in that schema reporting, we created 5 snapshot table in the last exercise. You remember this? So what I'm going to do is I am thinking of creating a stored procedure, and it will be a basic stored procedure with all the load queries for the 5 snapshot table wrapped into one stored procedure. So you see here, and I've added a delete query. So if you are running the same snapshot query again for the day, it will delete the entry for that particular day and will load the latest entry. So delete, insert, delete, insert, delete, insert for all the 5 snapshot tables I have created. Right. This code you will find it in. I will share the download link, and you can download it. So it's the same code, just formatted differently, because now we are not going to run it in an interactive manner. We want to run it via Airflow. So once this is up, probably I'll run this query. I will take a pause now. And once the servers are up, then we'll resume. Okay, the servers are up now. It took more than 1 hour for it to come up. And in the meantime, even my EMR cluster went down. It got auto terminated. So I'm creating the stored procedure now. It just have delete insert in it. So my EMR cluster also went down because of idle time of 1 hour. And then I have created a new ETL EMR cluster. And before we proceed running our DAG, I have to make a connection, and this connection will be for my Redshift. There are default AWS default and Redshift default, but just for the demo purpose, I will create a new Redshift connection and show you how you can also create it. So let me give it a name. I will select connection type as Redshift. I will pass the host name. I'll copy the host name from here. Database by default is dev. I will give the username. Then I will paste the password here. So this connection Airflow will use to connect to Redshift, and the port is 5439 by default. And I will save this connection, and this connection I have used in my DAG, and I will show it to you as well. We'll do a quick code walkthrough of the DAG as well. So it's a ETL SQL demo pipeline name, demo of ETL SQL pipeline that runs Glue, EMR, and Redshift loads. I will click on code. You can see there are total 6 tasks. And how the DAG looks like, you see I have imported the modules, basically the Glue job operator to run the Glue job, EMR for the EMR, Postgres operator for Redshift. I could have used Redshift operator also, but Postgres comes by default. For Redshift, I may have to install the Amazon library. Now initializing, I'm setting some default argument for this one. And this is the Redshift connection ID, which we just now created, right, with username and password. And this is the EMR cluster ID. So, okay, the EMR cluster ID has changed because I created a new cluster. It got terminated, previous one. By the time manage airflow came up, the previous EMR cluster got terminated because of idle time. So I created a new EMR cluster. So let me change the cluster ID now. You can make these values as a parameter as well. And I have changed the DAG name also. It's much better name than the previous one. So yeah, let me replace it with the new EMR cluster ID. So it will refresh. Now this is the tag, pipeline name, description, catch a false, tags, and here the task comes. So first one is the dummy operator, just like that, a placeholder kind of a thing for the starting. The first step is the glue job. So glue job, the same job which we triggered earlier, where it will read the raw CSV files, will add an additional column load date at the end, and we'll do some basic string manipulation like capitalizing the country name or lowering the email ID. So those basic things. So this is a Glue Hudi demo name. I have passed that name in here. You can see it is going to run this job, and these are the parameters it need. All these variables you can parameterize also. I have hard coded for now. Then comes the EMR, and this is the exact same Spark submit command which we use to trigger our job in when I connected via putty, right? So same command I have used here, and this is additional step. What happens is it will submit an EMR step, and then the sensor will continue to watch it. And the next step is the Redshift, where I am calling the stored procedure which I just now created. So that stored procedure which I created, I'm calling that stored procedure here, and I'm using the connection ID which I just now created, and then again a dummy operator to end. So this is how the flow looks like. We'll run the glue job, we'll run the EMR. EMR watcher will watch whether the EMR job is complete or not, and then the Redshift job will run. So you see here I've triggered the job and it is running now. And you can see the cluster ID has also refreshed. I will go to glue now, and if the job is triggered via Airflow, I can see it is running here. So you can see here, right, that the job was triggered via Airflow, and the same job I can see in glue, it is in running state. So my connection from Airflow to glue was successful, and I'm able to trigger a glue job via Airflow. This job will take around 3 minutes to complete. We already know it. So let the job run. You can see the input arguments, all the arguments which are passed to this job. This is the continuous log. So in Airflow also you can see the log, but that log will be more like polling and checking whether the job is still running or not. What is the status of the job? If you want to see the detail, you can come to the Glue console and check the driver logs. Furthermore, if you want to see the Glue logs, you can go to CloudWatch logs and see what are the error logs. So here you can see in Airflow, it is just polling and checking what is the status of the Glue job. It is still running. But for the detailed log, you can come to the AWS Glue console and see there like this. And furthermore, if you want to see more details about the logs, you can obviously go to CloudWatch for your error logs or the input output logs. So the job is running. So what will happen after this job? My customer, products, and transaction tables will be updated in Hudi. See, it is polling and checking whether it is running or not. It should complete any time now. Yeah, I can see it is writing into the data lake path, and it should complete any time now. So you remember, from reading from input files, then writing into output files data lake, and the EMR will read from output files data lake and will write into output files analytics, And Redshift will read those analytics tables and will create 5 snapshot tables, which you can further use for Amazon QuickSight or Tableau or any other reporting to show those snapshot data. Okay, so the job is complete as per the driver logs. I can see it is successful. Let me just refresh it and confirm. So you see here, the job is successful here. I will go to Airflow and you can see Airflow also has switched the status to success, and then the EMR start is in queue position. So EMR start is also successful. So the job is, to check that, you come to EMR and click on steps. So here you see a step is submitted, and you see the same Spark submit command which I shared earlier. So whenever manage Airflow triggers a job, it comes as an EMR step, and you can see the details here. And EMR watcher will keep a watch on it. So the job which was submitted earlier, in the next step, the watcher will just keep on polling whether the job is complete or not. Is it running? Has it failed? Is it successful? So it keeps on tracking the status. So I see the job has failed, and I think I already know the reason. Can't open file, and then it is mentioning the file path generate metrics.py, but the path is not correct. You see here, and let me go into Airflow also once. I can see that can't open the file, so it is not able to find the path where the file actually is. It is looking into some other path, but the file is in S3. And let me go, and so you see here, in here also, in Airflow also, I think we can see the same error. You see here in Airflow also, it is showing me the error that okay, can't open file, and then it is listing the path where it is looking for that file and it can't find it. And the reason is I am actually using a relative path rather than an absolute path. So what I will do is I will copy the absolute S3 path here, and I will replace it in my DAG. So in my DAG, I am giving a relative path right now for my EMR job. I will replace it with this absolute S3 path so that it goes to the right path and then read the file from there. So I have replaced it. Let me replace the DAG one more time. Now I will replace the DAG. So you got the error right, that I gave a relative path code EMR and then generate metrics.py. However, it took the local path rather than the S3 path. So what I am doing right now is, let me mark this job as fail, and I will re-trigger the job after some time. Once, so now what I have done is I have changed the EMR script path to an absolute path so that it goes to S3 only and read it from there. I'll scroll down and I'll show you where exactly this error happened. You see here the path, line number 62. So earlier I gave a related path like code EMR. So it was looking into the local disk. But now I have explicitly mentioned it is the S3 path, and I'm confident that now when I'll run, it will be able to read EMR file from the right S3 path. So I have triggered the job again, and it will go through again. I could have cleared the task and run again, but yeah, let it run again end to end. So you can see the glue job is running again. It will take around 3 minutes to complete. So you can see here in the logs, it will show you that it is polling and the job status is running. If you are following me so far, I hope you are liking the video. I hope you are learning something. If you have any comments, any doubts, feel free to drop a comment. You can also send me an email and I will try to respond to it. If you need any help with AWS data engineering, please let me know. I'm always there to help. All right. So in the meantime, we know that this job will take around 3 minutes to run. What we can do is, in the meantime, let's prepare our Redshift table for it, the snapshot table for it, right? So we already loaded some data into the Redshift table. What I am thinking is I will clean those 5 tables, and after this run, we'll check whether the data is loaded into my Redshift table or not, because my starting point is the CSV file transformed into Hudi table by Glue, then transformed into Hudi table by EMR, and then loaded a snapshot table into Redshift, right? So my final target table is my snapshot table. So at the end of Airflow run, my snapshot table should have data. So here what I'm doing is I'm truncating, or I am deleting all the data that exists in my snapshot tables right now. So I will delete on all the 5 snapshot tables. Let me verify whether all the 5 tables are empty now or not. Let me just copy and paste it 5 times and change the table name. So the first table is customer segment value. Category performance analysis. Don't focus on what is the table name, what are the columns. Just my intention is focus on how the different services are working together, right? It can be any data warehouse, it can be any data lake. It can be opposite also, that you are loading your Redshift first and then from Redshift you are loading your data lake, right? Data lake hydration. So yeah, I can see the first 2 tables are empty. The third table is empty as well. The fourth table is also empty. And the fifth table is also empty. Yeah. So all the 5 tables are empty. Let me refresh here. What is the status of the job execution? Okay, so this is successful. My glue job is successful. Let me see the EMR step. Where is it? I will refresh the table and I can see it is in running state. And you can see the command it has used. If you want more details about the logs, you can use the standard error or standard out logs. And the job is running. So you can see the command it is using, and let me refresh and start status. Okay, it is complete. So even the EMR job is successful, and it should also refresh and update the status here. The next step is the Redshift snapshot. So once this job is complete, it will trigger. Okay, so I see the EMR is complete and Redshift is queued now. And it should also be in running state very soon. Yeah, it is in running state now, and it should also complete very quickly. Okay, so it is also complete and you won. The last task is also complete. So yes, so you see, right, how with manage Airflow we triggered glue job, EMR job, and Redshift also. Let me query the snapshot tables and see how the data looks like, whether we were able to load. So you see here, customer segment data is there, customer activity data is also there, and you can see the snapshot date is also current, today's date also, and then the category performance also, and the top performing categories also, and the customer purchase frequency. So all my 5 snapshot tables are loaded now, And yeah, this is all I wanted to cover in this demo. You can see how we used Airflow to integrate all the services together, run end to end pipeline. And this is what you can expect in a typical AWS data engineering project. I did not cover the real time streaming, but mostly if it is batch, it will be something like this only, where you will be reading some data from the source and then transforming it using Glue, EMR, building data marts and data warehouse in Redshift, building data lakes using Glue and EMR in S3. So I think this was a good video to showcase that how exactly AWS data engineering works, the code. You see how do we place the code in S3, how where do we place tags, how do we install managed Airflow. It needs a private subnet, so what tweaking we have to do. So analytics is like your golden layer, right? Data lake is your silver layer. So we covered a medallion architecture. Also, you see here the date is used as a partition column, so there are partitions also. We created a customer metrics, product analytics. So yeah, this is all I wanted to cover. If you like this, please subscribe to the channel.